Evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Aptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Yes.
Good morning.
Good afternoon.
It is afternoon for me. Brian, how are you?
Doing well. Good to be back on the webinar.
Oh, man. I'm really excited about this one. I know that I posted this on LinkedIn, so whoever was kind of watching that. And I don't know if we talked about this the last time we did, like the OG build me a cluster when Brian came on and was like, okay, let's jump into it and do it. But it was kind of like an idea that popped into our heads the day before the live webinar. And so we're like, hey, can you do it tomorrow? And he's like, okay.
I work well under pressure.
Nothing like giving Brian some time.
No pressure. And that's like often, I mean, anyone who works right in the tech industry, there's the people who are just like, come on, man, build the button. I want to press the button. Just, you can do it. And then there's the actual engineers who are doing things and building things and putting together. Like, it's a little tougher than that, but you did amazing and people loved it. It was one of our most well-watched webinars. And so that is one of the reasons why we are back here today to continue to iterate on this idea of the tools that you can use for building a cluster.
Maybe we should have waited and not given Brian more notice than yesterday. Like teed him up. Went so well last time. I mean, hey,
yes.
The same plan.
Pressure. I think all of us in college kind of did that. We were like, oh, you know what? I do my best work when I don't study. And I cram the night before. So let me just do that.
Or the hour before.
Not the best plan. Just throwing that out there. Okay, so we are going to dive into it. So anyone watching, thank you so much for being here. Make sure that you like and subscribe and turn on the notifications so that you get a little ding and a ping when we are going live. Typically, we're here, same time, same place, Thursdays at 11 o'clock. Yeah, very excited to be here. So
no other pressure, Brian, but Jonathan just said he's sitting here with half a cluster. Yeah, he's ready to build the second part. So
All right.
Make sure you get him through it.
Oh, yes, for sure. We could definitely help you out with that.
So that actually kind of brings a little bit to the point, Brian. Is there anything about that first video that we need to catch people up on? Is there any background that we should give?
Not really. I was thinking the focus of this webinar would be you're trying to build an HPC cluster and you're some organization and you might not know where to start. And this webinar is to kind of give you some pointers on where you can basically start and what type of data points you should kind of collect, how you evaluate these types of solutions, and things like that. So yeah, we can kind of jump right into it. Cool. So I guess to start, you're some organization, you want to build an HPC cluster, and you're kind of looking for a starting point. And I think one of the most important parts of building an HPC cluster is to understand where this fits in your business. When you're a business, you have different needs, and you kind of want to understand how money's flowing in, how money's kind of flowing out. So I can kind of walk through a few examples here that I have a little bit of experience in. So the first example I'd like to talk about is academia. So you're a university. You might have some researchers who have some grant money coming in, and you as a IT organization might get some of that grant money to build out an HPC cluster. On the other side of that, you might have some budget set aside by your institution, and you might have money flowing in that way to build said HPC cluster. And yes.
Okay.
Right.
So what is the small, so when you say cluster, I'm imagining you have a head node and then you have at least 2 compute nodes that you are doing stuff with. Is there a small, how small can you go? How big can you go?
The smallest case I would kind of go with is maybe one head node and one compute node. And you can run most of, I guess, your scheduler, your storage off of your head node. And you could have your compute node that just runs off of that and basically computes all of the tasks flowing into your HPC scheduler. So that's like the smallest case that you could kind of go with. And then as your cluster gets bigger, you might not want to host all of these components on a single server because that's a single point of failure. If that server dies, it might be game over for you, right? So, you want to have things like high availability, maybe a storage appliance to give you a little bit better performance, things like that to make your cluster a little bit more scalable and manageable.
Okay, so then, sorry.
Sorry, Rose. Nope, go ahead. I have lots of questions.
I'm like really stuck on this like visual of how many. So if you had, because some of our clients, they come in, they're like, okay, well, we have, 3 head nodes and 1,000 compute nodes. So like, how would you do that? Like, at what point do you say, I need another head node? And then what do you do with all of your head nodes? Right? Like, so say you have 3 of them. Are they all individual? Do they have the one central place where you can manage them?
So I guess we should kind of define what a head node is, I guess first. So from my perspective, a head node is basically in charge of provisioning your cluster. So standing up your compute nodes with the scheduler client and basically, yeah. So provisioning is a component of the head node, and I would also put possibly the scheduler on the head node as well. So the head node would serve those 2 main functions. With the organizations that you've talked to that say they have 3 head nodes, maybe one of them is responsible for those functionalities, and the remaining 2 are kind of what I call like a login node, where the end user would log into these nodes and begin doing their work on. So it might not be used for managing the cluster, but it's basically used as a user interface for your customers to kind of interact with.
Thank you.
So maybe you'll go into this, Brian, but whenever you talk about academic institutions and people going to get grant money and budgets, I know I've heard the term condo model used quite often.
Oh, yes.
Is that something you're going to dive into?
Yeah, I could dive into that. Yeah, for sure. So within academic institutions, they typically operate in what is called the condo model. So what that is let's say your institution has a bunch of research labs. These research labs have set some budget for compute HPC resources. So these research labs basically contribute hardware to the institution's HPC cluster. And because they contributed this hardware, they basically have priority access to this hardware when they're submitting their workflows to the cluster. But the beauty of this is when their hardware isn't being used, it could be used by other research labs, which may not have a very high, like their need for results is probably not very high, so they can actually wait for their results. So even if their job sits within the queue for maybe hours to days, it's okay. But at the end of the day, these lower priority users are still getting their results, enabling them to do their research.
Thank you.
Yeah, no problem.
I feel like we've kind of taken you a little bit off track, but
I know, sorry.
So yeah, I guess to wrap up, that's a little bit of how the business of an academic institution would kind of operate. To kind of contrast this, I have a little bit of experience in the genomics space, and the genomics space has similarities, but there is the way that revenue is generated is kind of different. So with the genomics, specifically a sequencing shop, you basically have your customers who may be patients, they could be clinicians, and they're basically ordering these genomic screens to basically test for cancers, rare genetic diseases, stuff like that. So they're sending in samples to some lab. The samples are getting prepped. It gets thrown into a sequencer, and basically the samples get sequenced, and now you have some tangible files on a file system that need to be processed. So these obviously get processed through an HPC system using a genomics pipeline, and the output of that is basically variants that are found within the patient's genome, and that basically these variants are taken, a report is generated and given back to the clinician or patient, and using this report and this information, they can make a medical decision on whether to get specific treatment, getting a specific prescription for a type of drug, things like that. In the context of HPC, there is this whole production operation that runs the pipeline, generates the reports, and gets it back to the clinician. And then, that's one of the use cases of your HPC cluster. And then you might also have a R&D aspect to your HPC cluster where you have a bunch of bioinformatics developers who are developing new screens for new genetic diseases, different types of cancers that eventually patients or clinicians can actually purchase. And then similar to an academic institution, you might also have a research arm who's writing grants, doing research for these grants, and you could also have another revenue stream flowing into your organization that way. Yeah.
Awesome.
Question.
Yeah.
Let's throw that up.
Do clustered nodes need to be high performance themselves, or can you build on a set of lower performance nodes if the job is structured to support it?
Do cluster nodes need to be high performance themselves? I think if your workflow is optimized for the lower performance hardware, you can for sure build an HPC cluster using that type of hardware. Yeah.
I like it. Use what you got, man. Start where you're at.
For sure. Cool. So I guess the last type of business I can talk about is a simulation type of shop where you're designing some product, you run a lot of simulation, and where HPC kind of fits to that. So basically, in this type of organization, you have a bunch of R&D engineers who are basically designing some product. You might be doing crash testing, drop testing on the product, stuff like that, which requires simulation. But once all of this simulation is done, the design is finalized, your product moves to a production state where it's actually being produced and getting into the hands of your customer. So I guess where HPC kind of fits into this is if your system is performant enough, you can basically get results faster. Getting faster results gets you to a final design faster, and getting to a final design gets you to production faster. And by doing that, you can be, you might have the competitive advantage of being first to market. And, in certain industries, that could be a very big advantage.
So, Brian, I think you're going to talk about components here in a minute, but whenever you're talking about those different industries like that, each one of those, since they're different types of workloads, do they require different pieces of hardware or different types of networks or different types of storage? Are there specific pieces of infrastructure that match better to specific types of workloads?
For sure. It really depends on the workflow, which I can definitely get into in the next section. But I think we also have a question that we can answer. Any computer will do. Oh, the faster CPU architecture is designed for specific problems, then it will get the results faster. Very true. Thank you, Jose. All right, so jumping into, I guess, this component section. So from the context, I can speak to this from two perspectives, one from the genomics perspective, the other from a CAE manufacturing type of perspective. So from a genomics perspective, it really depends on what type of workflow you're running. So the types of workflows that I've kind of worked with are whole exome sequencing, which typically runs on CPUs. And I guess in terms of alignment and stuff, you can run these multi-core and sometimes multi-node, but I think typically these are run multi-core usually. And so from the perspective of choosing your compute, you might want to choose something that has higher clock speed. Maybe if you're doing alignment, you might require a little bit more memory. So nodes that have a lot of memory in them might be useful for your organization. With other types of sequencing technology that's used, some of these workflows sometimes leverage GPUs. So for example, a workflow that I worked with before may have taken 20 hours if you ran it completely on CPUs, but if you ran it on 8 A100s, the workflow actually ran in 20 minutes. So depending on, I guess, how urgent your patient needs these results, you can schedule them on the different types of hardware. From a, I guess, CAE perspective, these are depending where you're at in the workflow. So typically with HPC, there are two major components of the workflow which run on the HPC system. The first one is meshing your model, and depending on how granular your mesh is, you might require more memory when your mesh is more granular or more fine. The second aspect of this is simulation. This is typically compute intensive, and depending on how your model is partitioned, interconnect speeds might matter from that perspective. So you might have things like InfiniBand in your cluster, which speeds up the message passing of results between the compute nodes.
So like on genomics and these other bios, I know there's a lot of instruments that are used. Scientists using instruments. Is it important to take into account how all of this ties back to the instrument? So from a networking perspective, a storage perspective, how does that work and how do they interact? Does it matter?
So yeah, that's actually a pretty challenging problem sometimes to actually solve. So from a genomics perspective, your samples are going into like a sequencing facility, right? And your sequencing facility, your HPC cluster might not be in the same place as where you're sequencing. So the first problem before data even hits the HPC system is how are you going to get your data from point A to point B, right? From the sequencing facility into the HPC system. There are design considerations there that you should make in terms of like what is the data size that the sequencer is generating. So for example, in whole exome sequencing, I think to sequence about 100 patients in a sequencing run, that generates about 70 terabytes of data. So for one of these runs, you have 70 terabytes. That's on some storage server. You need to move this from point A to point B. And, depending on your SLAs, that will determine like how many parallel connections you need to your data center and all that type of stuff.
That can take a while.
Yeah. So yeah.
I've seen a couple of your charts where you're really laying out what do you want your infrastructure, what do you want it to all look like. So the interesting thing of like what I've come to understand is that there are options, right?
For
I
sure.
mean, from my mind, it's like, oh no, this is the one way to do it. And this is the right way. And that is actually not the case when it comes to your cluster. It really is going to depend on, well, first of all, what you have and what you want to do. So as you're designing how you want things to all piece together, there's iteration that can happen in the design phase, which makes sense, right? I mean, it's kind of like you're building anything. You want to make sure that it is designed the way that you want it for the function that you want it. and then you can, buy the different pieces and do whatever you need to do and figure out what software you want to use. So this is really helpful, because I think some people just jump into stuff, I mean, it's probably,
Yeah, for sure.
and then they end up calling us. They say, fix it.
Yeah, for sure. And jumping into just one set solution, like long term, it might be very expensive to operate. So, you might want to make changes to your infrastructure to kind of lower that cost. Yeah.
It's always about budget, Brian. It's always about budget.
Yes. Got the money got to make sense. The money got to math,
Mark that one. Wewe're going to cut that and use that for a lot of stuff. Money got a math. Done.
Yeah, so we've kind of talked a little bit about just overall architecture, but we can kind of jump into some of the software components of your HPC cluster. So I guess in academia, genomics, manufacturing, at the end of the day, you're basically doing science. And at the end of the day, you want your science to be reproducible. And I guess the first part of making your science reproducible is, having some set standard. And some organizations might standardize on a particular operating system. We here at CIQ support Rocky Linux. And if you need to basically standardize on a specific version of Rocky Linux, we offer long-term support, which gives you all of the security patches and all of that stuff to make sure your system is still secure while maintaining that specific version of your operating system. So that's from an OS perspective, that's what CIQ offers. But let's say you've decided on an operating system, and now you need to provision this to your thousands of nodes in your cluster, right? CIQ also supports the open source project Werewolf. And for the viewers who might not know what Werewolf is a stateless OS provisioning tool. The cool thing about Werewolf is that all your node images are basically containers. And the beauty of that is you can basically document your node image within a container file. That container file can be committed to source control. So all your changes to your node images are tracked and can be approved, for all of your compliance needs. Once it's in source control, you can have CI that automates the build of these, does tests with them, and pushes them to a container registry. From there, you can do all your security scanning, all that stuff before you actually consume this image on your cluster. Yeah.
Awesome. We have a comment, from Sean, sysadmin Sean. He says, "Hey, I'm doing the same thing on my channel. I love Werewolf."
I was just going to say, we've seen I feel like we say this every time we talk about Werewolf, but the amount of increased users that we're finding that are coming to us that are using Werewolf or migrating to it has been a lot of fun.
Yeah.
Awesome.
In the last year, there's been a lot of activity in the Werewolf community. They've been doing a lot of work at taking what it was and building upon it and iterating based on what customers in the community want to do. So there's lots of changes. So if you want to be part of that community and you just love the idea of provisioning and building clusters, then yes, Werewolf in Slack is the place to be.
For sure.
Okay, so are you going to show us something, Brian? Do we get to dive into a little demo, or what are we doing here?
I don't have a demo prepared, but there's more we could actually talk about in terms of the software perspective. You have your OS. We've talked about provisioning. We can dive into scheduling. Depending on your organization's needs, there are various schedulers to choose from. Some are open source, like OpenPBS and Slurm, and some of these might be easier to provision. So, for example, OpenPBS and Slurm, there are recipes to build clusters using these schedulers in the Open HPC community. So you can definitely check those out if you're looking to build a cluster with those schedulers. And, it really depends at the end of the day on your organization's needs. So jumping back to the academia example, if you need to prioritize, basically prioritize certain labs over others, you can do that with Slurm. I'm pretty sure you can do it with OpenPBS as well. I think if you want some report generating or a database of all of your job history, Slurm might be the better option for that need. So there's a lot of open source commercial options out there, and definitely a lot to choose from depending on your needs. And
Brian, I know you've done quite a bit with the open HPC stuff and Slurm and deploying, and I know you've built some automation around building clusters with that too, right?
Oh, yes. So yeah, we at CIQ have developed a little bit of automation that hopefully we can publish for more people to use, make deploying clusters a lot easier for the community and our customers.
The button.
Oh,
See?
yeah,
Button.
easy button.
Brian's been building the button.
Yes, the button.
Yes, cluster building button.
Yeah. And so I guess to kind of jump to the next section of this. So let's say before we do that, I guess before you choose these components, it's always ideal to get a reference point to evaluate your solution with, right? From, I guess, a genomics perspective, you have a pipeline that runs on some hardware. Maybe you want to take the most compute intensive step, benchmark that, and maybe you don't want to get some servers, rack and stack them, and run benchmarks on them, like as a POC. Maybe the cloud is a great option to kind of get your benchmarks. You can spin up a few instances, run them, spin them down, and at least you have some data points to make a educated decision on what type of hardware you should be purchasing that gives you optimal, cost performance. From a CAE perspective, benchmarking is a little bit more, I would say, rigid and a little bit easier. So with a simulation, you're basically simulating, for example, a drop test over some period of time. And basically, to kind of do a scaled down benchmark, you can maybe run one time step. And the time it takes to run that time step, you could use that to extrapolate to basically see how long it would take to run the entire simulation. And that time step could be run on multiple servers. You can keep increasing the number of servers to kind of get an idea of how many you would actually need with your cluster. So benchmarking is important, and make sure you have your data points before you're designing your cluster.
Yeah, validation is important. I talked to a group that spent several $1 million on infrastructure, and when it showed up, they realized the data center couldn't power what they bought, so they had to find another data center. It was not ideal.
Oh, yes. I feel like power is one of those things that often get neglected, but
yes, apparently so.
Yes, make sure you have enough power. That being said, also storage is sometimes also neglected as well. At least from a genomics perspective, like being able to model how much storage each of your, genomic screens actually takes, and being able to manage that effectively is sometimes a very challenging thing to do. Understanding how much it takes, and also having the workflow to actually archive some of the results to make sure that you stay HIPAA compliant and all of that type of stuff. So I guess to wrap up, let's say you have decided on your components of your cluster, and what are the next steps now? You've procured it and you just have a pile of hardware. What do you do with this, right? So, the next steps in this, you would basically rack and stack these servers, probably install your head node, get your provisioning set up, and basically start deploying and running probably running some validation on your cluster. If you aren't too experienced in this, CIQ can definitely help with this. CIQ offers professional services and also support to get your HPC cluster up and running, and support you through any issues that you might run into, and also train you up on how to manage your cluster effectively, so you are running a very smooth operation.
Yeah.
And you've done it a few times for us, Brian. We appreciate it.
Yes.
Taking the lead on it.
Thank you.
Got some really great customers over the line and fixed a lot of their problems.
For sure.
Fun to watch.
Okay, so head node, compute nodes, one or many. I didn't get an answer to, is there a limit?
I think your limit would be it would depend on your networking, I guess, and how many available ports that you would have that you can actually plug into your network switch. I think that would be the main limitation. Yeah.
Okay. And so say that you did get to whatever the limit is, say it's 1,000. I'm just throwing out a number. Then would you have to then have a separate head node for your next 1,000?
Not necessarily. I think what you would probably, so the choices there would be, depending on how you've architected your network, this might be very easy. It might be very easy to expand the next 1,000 of clusters. But let's say, maybe your architecture does not allow for that. Maybe an option that you could look into is maybe a hybrid model where you could burst jobs into the cloud then, if you don't have the capacity to actually make that expansion.
And then would you ever have a backup head node?
Yes. This really depends on your operation, but ideally, yes, you should have I would recommend having a backup head node, mainly for both provisioning and scheduling, but more so on the scheduling aspect, because if your scheduler goes down, basically work cannot be submitted into the cluster, and work can no longer be processed by the cluster as well. So it would be ideal to have a backup. Yes.
Yeah, this is great. I'm really loving this vision and planning idea, and really kind of honing that in for people that it is important to understand where you are at and where you want to go, because the way that you set it up is going to define how easy or complicated, or even if it's even going to work smoothly, it's going to work. And then what you need, right? Where it's okay, wow, okay, we're setting it up, and this is this way. This is where we're at. This is where we're going, and we don't have enough storage. I've heard that a few times.
Oh, yes.
Yeah.
Okay. Got a good question from Mr. Rush. Welcome, Dave. It's always good to see you.
Hey, Dave.
Is bigger, or can clusters get larger but deliver diminishing performance returns?
It depends on from a simulation context, depending on how your model is set up, there will be a point where you scale the simulation up to a certain number of cores, and you will get diminishing amount of returns on that. So as part of benchmarking, the goal is to basically find that sweet spot that gives you the best cost performance.
The sweet spot. That sounds like kind of like a trial and error. You might have experience and you might know, but you don't know that you went over the line until you went over the line.
Yes, for sure.
So yes, but very dependent on the code.
Yes. Depending on the code, depending on the model as well.
Okay, so you
Thank
talked
you, Dave.
about Rocky, although really, I mean, it's operating system kind of agnostic when you're building a cluster. We just obviously talk about Rocky because at CIQ we do support and customization and cool things around Rocky. Okay, so you got your OS, you've got your provisioner. Again, we recommend Werewolf for many reasons. Not perfect for everyone, but that's the one that we love and appreciate and are working with. So if you're curious about that. Then what else? Because you mentioned containers, and I know that we often have like an HPC stack where it's Rocky as the OS, Werewolf as the provisioner, and then Aptainer as the containers. Where does that fall into what you're talking about here with your cluster, and why would you even want to use containers?
Oh, so all right. So going back to the point of being able to going back to the point of reproducible science. Basically, uh, with a container, to build your container, you need a with Aptainer specifically, you need a definition file, and basically with that, you get all the nice things of committing it to source control, CI, all of that's your build is the build of your container is basically documented in this definition file. Being able to share your container with others enables others to basically generate the same results as you and understand how your results were even generated in the first place. So it kind of enables them to validate your results, whether you're doing research, you're doing some type of manufacturing, for compliance reasons, all this stuff needs to be validated. Aptainer can basically enable that, which at the end of the day is reproducible science.
Awesome.
Yeah.
We also provide support for Aptainer.
Yeah.
Okay, so we got the OS, we got the provisioner, we've got the batch scheduler. We don't provide any support for that, but you need a batch scheduler, and then you could probably use containers. I've seen that people that don't do it, but we recommend it, and for the reasons you just gave. You need to understand what your storage is, what's going on with your power, what your networking capabilities are, and obviously all of the hardware that you're working with.
For sure.
Did I miss anything?
Maybe the last component of this is like the user interface, right? So depending, like really understanding the end user, where their expertise are, like typically, traditionally an HPC cluster just has a login node where users SSH into it, and basically run a bunch of bash commands on a terminal. And maybe not all users are comfortable doing that, right? And as a result, you might want to deploy some type of web interface, for example, open on demand, that gives a user some web UI where they can click around, click submit, and see their job run, view logs, stuff like that. And CIQ offers Fuzzball, which is basically a web UI that you can hook into deploy onto your HPC system to enable your users to do that.
That's really cool. That's another reason, and I know that Fuzzball uses a lot of containers as well, but that's another reason to use Aptainer in an environment like this is because it's a little bit more friendly. It's not really a web interface, but it's a little bit more friendly way for people to tap into the resources of the cluster that your company is building out.
For sure. It also enables the user as well. You don't have to go to, your cluster administrator, ask them to install this software for you. You can do it on your own. And as long as you have this container, you can put it on your system and, you're off to the races, right?
We got a lot of good quotes here.
That's fantastic.
Good. So what do you got, Zane? You got any questions? Anything that's coming to your mind?
No, he answered most of mine.
Yeah. I think I'm questioned out too. That was thorough, stuff, man.
It was thorough.
It was very thorough. I'm looking if we have any more questions.
Thanks to Sean, Jonathan, and Dave Rush for asking questions. Appreciate it.
Yeah.
It's good to hear from you guys.
Awesome. Yes, I know Dave, he probably wants everyone to know you can build a cluster with a Raspberry Pi as well. So I've seen him do it. There is a picture of me and Dave somewhere with a Raspberry Pi cluster. So that's awesome. Thanks for sharing that. Lots of cool things you can do with computers.
Sure.
Alrighty, is there any follow-up or wrap-up that you want to give, Brian?
If the audience has any particular topics about building an HPC cluster, please drop them in the comments. And yeah, we can definitely do a webinar on those topics. Yeah, just let us know what you want to see. And yeah, we'll try to put it together.
Okay, so
Call us. We can help you out.
Yes.
Or call us.
Yes, exactly. So my bet is that someone's going to want to have a little bit more understanding of the Slurm werewolf working together. That's actually been something that has come into my awareness. So maybe we'll talk about that at some point.
Okay, that sounds good.
Awesome. Well, thank you, Brian.
Thank you, Brian.
HPC cluster genius. Thanks for coming on and sharing your knowledge and your wisdom and expertise with us. As we kind of have mentioned all through our little webinar here, CIQ, we are so happy to have conversations and put Brian to work, okay? Because he's bored just sitting there waiting for someone.
I'm sure Brian's bored. Look at him.
Not bored, but he's not the only one. So yes, we would love to chat with you about Werewolf, Aptainer, Rocky, the automation. So we have a Sender automation platform, which we're like starting to put into all of our different products as well, so that it's simpler and easier and faster and more effective and efficient for our customers and getting that little, push the button
and repeatable.
Yes,
predictable.
Absolutely. And predictable. Yes. It's the simple things like when things just work.
True.
As you want them to. So there you go. And that's actually the feedback I've gotten about Werewolf. It's like, it just works. It does what it says it's going to do, and it just works. So thank you, Brian. Again, like and subscribe, share this, set the notifications so that you get a little ping. We're here every week, Thursdays, 11 o'clock Pacific time. So wherever you're at, this is the time. And have a wonderful day. We'll talk to you soon. Bye-bye.
Thank you, everyone. Thanks, Brian.
See y'all next time.